All right, so we're going to look to find the inverse for each of these where they exist, and I'm going to go back and use those formulas to help me as well. So the first thing, we know that the inverse exists if 3 and 7 are relatively prime. By inspection, I know that the GCD of 3 and 7 is 1, therefore the inverse exists. So now I'm looking for some A inverse that I could multiply by 3 and get 1 mod 7 as and get 1 as my remainder. This will be my inverse. So one thing I can do is to solve it by inspection. Yeah? I can see that if A inverse is 5, then I would get 15, which is equal to 1 mod 7. So my value is 5, but of course inspection's not a way that's always going to work. So I'm going to go back to what we saw with in our previous divisibility section and our modular arithmetic section, that I could have the GCD of 3, 7 be equal to some 7x plus 3y. And the reason I'm doing this is because I know that it's 1. Yeah, so 1 is the number that I'm looking for. I'm looking for my 1 mod 7. So this is giving me values and ways to find the 1. All right. The way that we found the GCD is using the Euclidean algorithm. So we started by saying that 7 is equal to 3 times 2 plus 1, and then 3 is 2 times 1 plus 1, and then 2 is 1 times 2 plus 0. So as soon as I get remainder 0, I come back to the previous line. That's my GCD, my remainder of the previous line. And then I can rearrange this to end up in this form. So I'm going to start by saying that 1 is equal to 3 minus 2 times 1. 1 again is going to be equal to 7 minus 3 times 2. And that's what I want in my equation. I want my 7s and my 3s. So I'm replacing this one with 7 minus 3 times 2. So that means I'm going to end up with 1 is equal to, that's going to end up being 4 3s and 1 more, 6 times 3 minus 2 times 7. Okay. Of course, though, if we end up with this, then we've got something, I feel like something has gone wrong here. Did I miss something? That's going to make positive 4. That's going to be 5, not 6. Okay. So, looking at this, I could say that my x naught value is 5, and y naught, my initial values, are negative 2. But thinking about trying to come up with a mod 7, I know that anything here mod 7 is going to be 0 because I'm multiplying by a 7. So really what I'm looking at over here is my 5, because I had my 3 mod 7 from my initial constraint. So what I'm looking for is my 5 here, because that's what's going to give me my remainder of 1. So this value is also going to give me my A inverse value. Right. So that's solving for the multiplicative inverse. I'm going to make another video for the next two.